Hello and welcome to another math video. Today we're talking conditional probability. I'm going to start out by just presenting this situation. We're not going to take the time to really get into it on this video, but just want to kind of get you thinking about it. So in this case, we've got a prize inside box 1, 2, or 3. You pick box 1, and what they do is they show you then that box 2 contains a rubber chicken. You're given a chance to change your choice, and so the question: should you stay with box 1, or should you switch to box 3? Now, through some of what we're doing here, we'll be able to help you determine what you should do there. And a big part of that is: does your probability increase, decrease, or stay the same by either staying or switching? You know, staying with box 1 or switching to box 3. And there is a correct answer there, you know, and again, I'll throw out all the options there. Either the probability increases, decreases, or stays the same. So the correct option is one of those three. Like I said, we're not going to take the time in this video to go through all that, but it is quite an interesting probability question if you feel like digging into that a little bit. So looking at the probability that event B will occur, given that event A has already occurred, is called a conditional probability. Conditional probability exists when two events are dependent. So again, they have to be dependent events. Here's just some notation about how to write conditional probability. So the conditional probability of event B, given that event A occurs, looks like this. So the probability of event B, given that A has already occurred. So the probability of event B given event A. We'll use tables, tree diagrams to help us find some conditional probability. Now, given a table like this one, we can find some different things. For example, this first part A, find the probability that a student is female given that they are in graduate school. So what we do there is we really only look at this bottom row of our table because it's a given that we're looking at just graduate school students. So we've got all that information: 2-year colleges, 4-year colleges, graduate schools, males, females, and of course our source is the U.S. Census Bureau. And these numbers are in the thousands, so add 3 zeros to those numbers. But anyway, that's what we do. We look at just this bottom row. So it's, other than that, it's a regular probability. So I'm going to go ahead and calculate some numbers, write those in. So I'll pause so those will just pop up. Okay, so I went ahead and put in those numbers. Again, the total for each column, each row, and the overall total, 17,472 in the bottom right corner. So we're looking at just the probability that they're female given that they're in graduate school. So total number of graduate school students, and again, I'm just kind of not worrying about the fact that these are numbers in the thousands, it was 3,303. So that's our denominator. And of that 3,303, the number that were females was 1,954. Now in these cases, it's certainly fine to approximate. Again, the numbers are already in the thousands. We should say either about or use the approximation symbol. This one turns out to be about 59.2%. And I'll just like to go to that 0.2%. That way it's clear where I'm rounding to for that kind of problem. So about 59.2% of graduate school students really are females. And then the next question, just what is the probability that a student is female given that they're in this setting really? And so we've got all the data for 2-year, 4-year, and graduate schools. And so then we're looking at total females for all of those. Well, that's the 9,933 divided by the total number, 17,472. And again, don't worry about trying to reduce these fractions or anything. They're not going to be nice numbers. This one turns out to be about, or again, we can use the approximation symbol, 56.9% is what we're looking at there. So you can see the increase in the percentage of females that are in graduate school compared to females total. So And what that would imply would be that a higher percentage of females are continuing on to graduate school from the 2-year and 4-year colleges. You can go ahead and try the problem at the bottom. So probably that they're a 4-year student, given that they're male. If you want to pause, and then I'll go ahead and go through that one. So given that they're a male, now we're looking at just the male column, which is 7,539 for the denominator. And given that they're a male, probably they're in the 4-year, well, that's 4,324 males there. So again, finding that probability, I get about 57.4%. So that's what that looks like. And then the next, bottom question there, without even calculating, given a student is enrolled in a 4-year college, is it more likely for the student to be male or female? Again, you can just look at the 4-year college numbers. The number for females is higher, so more likely for a student to be female if they're enrolled in a 4-year college. All right, very similar kind of piece here. We're talking municipal waste collected in millions of tons. We got different materials, how much was recycled, how much was not recycled. And again, those aren't percentages, those are tons. What is the probability that a sample of recycled waste is paper? So a sample of recycled waste is paper. Again, I'll go ahead and fill in my totals, so those will pop up there. All right, so I got my totals, at least for the columns there. And again, what we're really looking at in this one is probability that what we end up with is paper, given that we're looking at recycled. So that means we only look at the recycled column, and we end up with 45.2, which is the amount of millions of tons of recycled paper out of the 79.4 millions of tons of just total stuff that's recycled. And so we divide the two, the 45.2 by the 79.4. We end up with about 56.9% for that one. So again, the probability that a sample of recycled waste is paper, we're talking 56.9%. And then looking at the last two questions there at the bottom, again, you can give those a shot, and I'll fill those in if you want to pause and then start it up. I'll go through those. So looking at what is the probability that a sample of recycled waste is plastic, we'd really do the same kind of situation. We would divide, we're looking at just the recycled column, so 2.1 recycled tons, millions of tons of plastic, and that gets divided by the 79.4. And we get about 2.6%. And what's the probability the sample of recycled waste is glass? Well, we get 3.2 million tons divided by the 79.4. And that's about 4.0%. And again, the 0.0, even though it's nothing, is important because then that shows that I did round to the nearest 0.1%. All right, so conditional probabilities. In those last examples, we really had all the information we could ever possibly need to answer any and all of those questions. But you may not always have that. So in order to find the probability of B given A, we can use this formula if we just know the probability of A and B and the probability of A. So in that case, we wouldn't need all of that information in the table. So this is a formula you are going to want to be familiar with. So write it down a few times so that you have that handy. And in the numerator there, it does not make a difference if you think of that as the probability of B and A or A and B. They're the same thing. But whatever the condition is, that's the probability in the denominator. That can kind of help you remember that. So we've got here a utility company asked 50 of its customers whether they pay their bills online or by mail. What is the probability that a customer pays the bill online, given that the customer is male? And again, we do have the information we need, but I want to show you what it looks like to calculate it using that formula. So again, kind of forcing us to do this to get used to what that formula is going to look like and how it's going to handle. So I've got this worked out here already. Again, here's our same formula we had. So we need online, given that they're male. So male and online is the top probability, and then male is in the denominator. So again, that given condition, that's the bottom probability. Now male and online, that's 12 out of a total of 50. And probably that they're male, well, that's 20 out of the 50. So we end up with, and I'm not going to necessarily write it the same way they do. So our numerator is 12 out of 50. Denominator would be 20 out of 50, but instead of writing that as a denominator, I'm going to use the division sign. So divided by 20 out of 50. Now this is just going to handle a little bit nicer because then we just do the reciprocal and multiply. So multiply by the reciprocal of 20 over 50. So then that would be 12 over 50 times 50 over 20. The 50s cancel out. We really get 12 over 20, which of course reduces by a factor of 4, and we get 3/5 as the result. That would be exactly 60%. 3/5, of course, is an acceptable answer as well. But, you know, if we want to go percentage, that 60% works also. All right, so here's another one you can try about shampoo. So if you want to pause, then I'll go ahead and work through as well. So researchers asked shampoo users whether they apply shampoo directly to the head or indirectly using a hand. What is the probability that a respondent applies shampoo directly, given that the respondent is female? So if I write that out, we're looking at probability of direct application of the shampoo given that its person is female. So that's going to equal probability of female and direct over the probability that they are female. And again, I know I've got the table. I could find all that information, but I want to get you used to the formula when we don't need it. That way when we need it, we'll understand it that much better. Okay, so female and direct, that's only 6. And did they say how many people, or am I going to have to figure that out? Looks like I'll have to figure that out. So, let's see, this is 30, oh, it's 50 again. 30 and 20 makes 50. So, it is 50, so 6 out of 50 for female and direct. And again, I'm just going to say divided by probability of being female, so that's 30 out of 50. And again, this works out very nicely because we just multiply by the reciprocal by 50 over 30. So again, then that's a multiplication. The 50s cancel out. We get 6 over 30, which does reduce by a factor of 6. So that's 1/5 or 20%. It's kind of a silly question, but probability that shampoo is applied directly, given that the shampooer is female, is 20%. Here we've got the same sort of questions. Again, if you want to give these a shot, I've already filled in some of that important information, but if you want to pause, I'll go ahead and go through these as well. So the first question, probably that the person has a laptop to take notes, given that they're male. Again, I think in this case I'm just going to be using the table. You could, again, use that formula to help get used to that, but I just want to show you what the right answer is. Hopefully you're getting it on your own. So laptop, given that they're male, so we only look at the male column, and so we'd be looking at 27 over 71. And again, I'll let you do the rounding and things just to kind of speed the process along. Probably that they're female, given that they use a voice recorder. Well, so there was only 1 female in that row out of 3 total people in that row. Just the probability of pencil and paper would be 70 out of 133. And probably male given pencil and paper would be just that row, 42 out of 70. And again, I'll let you just reduce and come up with the percentages there just so you know, but those are those answers that we would have to deal with for those problems. here we're going to really look at using our probability formula for finding the probability of B given A. And this is, again, up here. You may want to write this down somewhere. I know I did. Which tells us the probability of B given A is the probability of A and B divided by the probability of A. We can also rewrite that formula solve it for really the probability of A and B. And then what we see is if we want to find the probability of A and B, we can just multiply the probability of A by the probability of B given A. So we can use that along with tree diagram to find probabilities for dependent events. And so we've got the situation here where we've got some information. School compiled the information from a survey sent to people who were juniors 10 years earlier. It said 85% of the students graduated from high school. Of the students who graduated from high school, 90% are happy with their present jobs. Of the students who did not graduate from high school, 60% are happy with their present jobs. And they want us to find the probability that a person from the junior class 10 years ago graduated from high school and is happy with his or her present job. And so what we'll do is we'll make a tree diagram. Here's where I'm going to have to scoot this up so I've got some room. So moving this up. Okay, so actually I might even go a little further. Let's see. So what we're going to do is we're going to do a tree diagram. So it's going to be green because it's a tree. And so let's see. We're going to do the 85% here. That's for the 85% that graduated. That means that 15% did not. Normally I'd label those, but well, I guess I could do that. Okay, so graduated and did not. Okay, so we break that down. Now, of the students who graduated, 90% are happy with their present jobs. So what we do is we branch off. And I'm actually going to change colors just so it's a little bit more obvious. So branch off. So let's say this is happy about their job, and that's 90%. And then that would mean then that 10% are not happy with their job. And then if they did not graduate, it looks like this. We've got 60% are happy, so I'll put that down here. 60% are happy. I'll just do H for happy. And that would mean then that 40% are not happy. I'll just do NH. So we've got these different branches for our tree then. So like this branch up here would be graduated and happy. We've got graduated, not happy. And we've got did not graduate, not happy. And did not graduated, did not graduate, and happy. So you got those different branches. Now, the question they had for us is, what is the probability that the person graduated and is happy with his or her present job? So, probably that they were graduated and they were happy. So what we have here, well actually, so I guess this is really graduated or happy, sorry, let me undo that. Happy given that they graduated. This is not happy given that they graduated, and so on. So in terms of our formula, we're trying to find the probability of they graduated and they're happy. So graduated and happy. And so really what we do is we do the probability of graduated multiplied by the probability of happy given that they graduated. And so those are the two probabilities that we have. So graduated and happy would be the product of 85% and 90%. In this case, and the tree diagram really kind of makes that clear that you just multiply those kind of consecutive values along that branch together in order to get to the end of that branch. And so we just figure out that percentage. So 85% multiplied by 90%, and we get 76.5%. And so that's what we end up with for that one, 76.5%. Let's see, their additional question, what's the probability the student from the junior class 10 years ago did not graduate and is happy? Let's see. And, okay, so that's really did not graduate and is happy. So that is down here. Did not graduate and is happy. And again, this is happy given that they did not graduate, really. So really we just multiply the 15% by the 60% to get the probability that they did not graduate and they're happy with their job. So probability of did not graduate and happy ends up being, again, the 15% times the 60% ends up just being 9%, what we're looking at there. And so that's how that tree can work. And again, of course, you could use that formula any which way. So as long as you know two of the three, you could use those two to find the other three, or other one. As always, thank you for watching, and hopefully you found this to be helpful.